Hi all, in this second lesson of the unit we're gonna talk about the tools to modify networks, loops and paths. Loops are closed set of connections along streams or across heat exchanger. They follow convective enthalpy flow or thermal enthalpy flow. And its distinctive characteristic is that they are closed. They start and end in the same side of the same heat exchanger. Because of that, the number of jumps between cold and hot side is even. And if you modify alternatively as negative, positive, negative, positive, the duty of heat exchangers, the whole network will remain in enthalpy balance. And the same thing will happen with every stream. Realize that this doesn't put any condition on temperatures, and temperature difference can become violated. In this example, we are just creating a new heat exchanger 5-star with a zero duty and translate heat from other heat exchanger to this using a loop. We want the heat exchanger with a duty of 200 kilowatts, then the next heat exchanger in the loop will be subtracted in 200 kilowatts, which will eliminate the heat exchanger number 5. The next one summed up 200 kilowatts, and the last one who closed the loop subtracted in 200 kilowatts. The result is eliminating the original heat exchanger 5, creating a new one with the same duty, or if you prefer, translating heat exchanger 5 to 5-star. The duty of heat exchanger 6 has decreased and the of heat exchanger 7 has increased. And in this case, temperature approach have been respected, but could have been not. The other tool we use, the paths, are very similar to loops, but they are not closed. They travel between a hot utility and a cold utility. And as the number of jumps between hot and cold side, or the other way, must be even, for the network to remain in balance, the duty, the heat flow of heating and cooling must increase or decrease in the same amount. Of course, every stream except heating and cooling remain in balance. But as when using loops, the temperature approach can become violated. In this example, we want to augment the duty of heat exchanger 6, that is a heater, to 400 kilowatts. Then we add the needed amount to the duty, subtract the same amount the next heat exchanger 4, and add the same amount to this cooler. Heating and cooling has been augmented in the same flow, as you can see in the result. The network and streams remain in balance, which is a great help. And in this case, as the utility augments, also the difference in T increases. which can allow for some savings. We use another path to tighten the temperatures, reducing at the same time heating and cooling in the same amount. It can be seen in the results how temperature difference had been reduced as well as utilities has been reduced in this last stage. Because from the original values, the original network, the increase in heating has been 7.2% and 7.5% in cooling. Working this way with loops and paths, we can easily, more or less, modify the networks. Remember that loops doesn't affect utility consumption, but paths do. Then it's very common to use loops to perform our desired modification and then using paths to restore the violations. But there are not strict rules for that. And this is all for this second lesson.